Okay everybody, welcome to the third part of the budget beginners quad build. If you missed the first two, just click on the link and you can start watching from the beginning of the series. Now you'll notice what I've done here is I've just temporarily fixed the arms onto the bottom of the frame. And this is basically so we can get an idea of what our cable runs are going to be like. Now I've actually pulled the flight controller out of its plastic housing and I've decided that I'm actually going to do a 90-degree offset on the flight controller so we can easily access the USB port on the side. You'll notice that there's a little arrow marked on the board here. That is its native forward position, but yeah, I'm going to flip it around 90 degrees and we're going to load this board up with the CleanFlight firmware, and it's very easy in CleanFlight just to set the offset so that this isn't a problem. So this is going to be the back of the quad and this is going to be the front of the quad. Our motor numbers according to CleanFlight are 1, 2, 3, 4. 1 and 3 should be the clockwise motors and 2 and 4 should be the counterclockwise motors. So I've just double checked all that and put the arms on this way, and now we're going to just mark out the cable lengths for, first of all, the cables that go from the ESC to the flight controller. So basically what I need to do is just roughly sit the ESCs in place. The way that it's going to sit is it's going to be like a sandwich like that, and this top plate here is going to sit touching the arms. So any cable runs that we have to go either side of that entry point in the arm. So what I might do is I'm going to bring all the cables on the inside of the arm. So the cables will actually end up going something like that. Now we can see the 4 holes where the flight controller will mount. So then going by this, actually my ESC leads are way too long. If I mark it there and cut it there, that one's going to be fine. So yeah, it does still look like a fair bit of a mess, but now what I'm going to do is actually just cut these here. Now the red 5 volts wire we only need from one of the ESCs. It's enough to power our flight controller and receiver with just one of the ESC's 5 volt line. But maybe we're going to want to power a camera or some other gear or something. So I'm going to take the 5 volt lines off the rear 2 ESCs and I'm going to leave them on the front 2 ESCs. So my next step, cut the cable to length, remove the 5 volt rail on the 2 rear ESCs and then resolder them to the board. And this is going to clean up all this wiring a whole bunch. Okay, so the first thing I'm going to do is just find that mark and chop it. I need to strip this back. It's actually really simple to just remove one of the wires just under the little tiny plastic tab, and then the red wire will just slide out like that. And then we haven't actually damaged it. If we need to put it back in at a later date, we can. And then you see now everybody's advertising, hey, twisted cables. Well, you can make your own twisted cables pretty easily. And now we just need to strip this off. And then tin the wire. Now we just clip off the excess. And then this is ready to go back onto our ESC. So the next step is to just remove the part of the wire that I don't need, and obviously I've got to remember where the black and white cables are because they're the ones we're going to be using. And we'll just heat those up. And they come off quite easily. And now I just want to solder the black wire on, which, guys, this isn't the easiest thing to do with a camera. And then the control wire And now that one is good to go. Now I just have to repeat with the other ones. Now the last modification I'm going to do to the ESCs here is I want to take this wire across this side of the arm. Now the way that it's joined to the board, it doesn't make it easy to do. And with my multimeter here, I can prove that the positive leg of the cap and the positive incoming rail there are already joined together. So what I'm going to do is just desolder this leg and solder it in the direction that I want it to go. Now obviously we need to be really super careful that nothing's shorted that shouldn't be. There's no holes in the insulation or anything like that, which there isn't. And now I'm going to go around and do the rest. So now we have our wiring ready to go. The next thing that I want to do is actually heat shrink the ESCs to the arms. Okay, so I've got 4 bits of heat shrink big enough to cover the arms and the ESCs, but they're not going to get in the way of the mid section of the frame. So next step is to remove the arms from the frame and put the heat shrink on. And I'm actually going to do this one at a time because I've cut all the cables to the length, so I don't want to mess up which one was which. I could label it, but it's easy enough just to do it one at a time. So now we have our ESC, we have our little plastic guard that's going to stop us from shorting out onto the carbon fiber. We need one of our heat sinks with our thermal pads, and now I'm just going to lay out that thermal pad and remove this so we've got a nice shiny surface. Stick him down, make sure there's no wires getting in the way, and I'm noticing that we're not fully covering the FETs and the voltage regulators. So the main thing is for this one is to cover the FETs, because actually the voltage regulator on this particular one is not being used. So now we have our little sandwich. We have carbon fiber arm, plastic insulator, ESC, heat transfer compound, and heat sink. And now next we need to put the heat shrink tubing over the whole lot, which is easier said than done. And now we need to shrink it down. I think that looks pretty good. We've got our cables coming out where we need them to come out. Okay, so we attach this one back onto the arm, and now we need to go ahead and do the other 3. Okay, so now you can clearly see that we have our ESCs with the heat shrink on the arms, and all the wires are looking good. So we're getting at the stage now where it's starting to look like it's going to come together. So now we can just push this aside for now and grab in the other half of our chassis, and now we need to connect our standoffs, and it's probably a good idea to put a little bit of Loctite on these. And you are going to need a 2mm Allen key bit just to go around and tighten these up. Don't need to tighten it up too much. Okay, and now we just need to put our standoffs for the power distribution board and flight controller. And these also came with the kit, which is pretty cool. So basically the way it's going to roll is we're going to have this kind of deal here with the power distribution board, and then we'll have these extra nylon standoffs, and then we will have our flight controller board sitting on top. So it's going to end up something like that. For now we're going to remove the power distribution board and we're going to start to assemble the frame. So at this point we need some kind of tape. We'll flip it over and just tape down these screws so that they don't fall out. Now we need to take off these nuts, and this is where it's going to get a little bit tricky. And the idea is that I want to just get the nuts started. I don't want to get them all in place and uptight just yet, because I'm going to need to move around the wires a little bit in between the two. So actually the less tension on them the better at this point, but I just want them done up so that the whole thing can't pop apart. Now at this point, now that I've got these two on, it's probably a good idea to try to sort out this. You can see here this ESC wire is pinching underneath, which is stopping it from going all the way down, and same on the other side. So I just want to clear those out of the way, and then I'll go ahead and get the next two on. I'm not too worried about where they end up in the middle at this point. I'm more worried about getting the wires going into the correct places adjacent to the arms. There we go. Get this last one, making sure that we're not pinching the wires. Now I can remove the tape, and you can see that the mini quad is really starting to look like a mini quad. Now what I need to do is get all the power cables coming up through this middle section and all the ESC cables coming up through this section. Okay, so we're getting there piece by piece. You'll notice now I have all 16 of these arm screws done up. They're not done up super tight yet, just enough so that I can work and I can see where my tolerances are. Now a couple of little pointers. The main power cables for the ESCs I brought inside these standoffs. And if you look in the side here, you can see that these standoffs kind of close this gap here. So they're a good way of sort of keeping that cable neat if you put them on the inside. So now I have all my power cables in this section here, and I have all my ESC signal cables on this section here, and I've just got them tucked out of the way at the moment because I want to deal with the power first. So the next piece of the puzzle is the power distribution board. And you can see here that it's going to sit here like this. I want to keep the switches on the underside so that they're protected and easy. If I just sit that on there, you can see that I've got half the cables there ready to be soldered on the underside, and these ones that were already a bit longer, I might take them up through the center hole here and solder those to the top side, just so it's not crazy congested underneath there. And there should definitely be enough room for the CC3D flight controller to sit on top without any issues. So the first thing I need to do is get the power distribution board ready for soldering by tinning all the pads. Now the first thing I'm going to do is tin all these pads on both sides. Now this is actually a two-layered circuit board, and the way that the layers are joined are with these tiny little holes, and these are called via holes. Now you can see they've put 9 via holes per pad, and that's pretty good, but if we fill those via holes with solder, then obviously their power handling capability gets increased by a lot. So I'm going to try and fill those holes. Maybe we don't need it, but it definitely doesn't hurt. I'm using solder with flux already in it, multi-core flux solder. Now I'm probably not even going to use all these pads, but I might as well just tin it all now, so that if I do want to make a quick addition or something later, it's more simple. And you can see that with the multi-core flux solder, it's really simple. Just add a little bit of heat and some solder, and it's good to go. Now I'm just going to try and work the solder down through the via holes, obviously taking care not to bridge any plus and minus pads. And now you can see that actually the solder has gone down through and joined the board, so this is great. And now I'm going to add some more solder on the back side. So now comes the tricky bit. It's only tricky because it's fiddly. I have to join 4 wires to the underside of the power distribution board. Now I'm sort of hacking this a little bit. This PDB wasn't really designed to be connected to the other side. So I just obviously need to double, triple check which pads are plus and which ones are minus. Hi guys, sorry about that, but I just realized that my camera battery went flat, unfortunately, which is a bummer. I really did wrestle to get those wires on the underside there. but in the end I got them. I would suggest that you need a pair of needle nose pliers like this. So anyway, now I'm going to do the top side, which hopefully is going to be a lot easier. Okay, so obviously, or maybe not obviously, but through the course of all this, we need to make sure that we didn't confuse any pluses and minuses, and an easy way to tell is to just get a plus and a minus, and I've got 480 ohms resistance across there, which is fine, and full connection there. So if one of them was shorted, I would have got a dead short across there, but I'm not. You will get an impedance because obviously it's going through the coils of the motors, so there is resistance between those terminals, but it's not a dead short. So by that we kind of know that all the wiring is good, or at least that there's no shorts. Okay, so the next thing I'd like to do is install the battery connector. So I've just got my battery wires, which I'm going to tin, and for tinning big wires like this, you really need to let the wire heat up and let the flux suck into the wire. It can take some time. Make sure it's all covered. You know, this is where all the power for the quad is coming, so it's important that we've got a nice solid connection. And we use our nice little bits of heat shrink that were provided with the kit. We also need to tin the connector. If you haven't soldered before, tinning just means preparing a wire or a connector by covering it with solder and flux so that it's ready. You can see there I've got a covering around the pin. Now a lot of people use bench vices and things like that. I have a good bench vice here, but I just wanted to show you a good little trick. Basically you can use one of these cheap plumber's tools to hold what you're soldering in place, and it's a lot cheaper than going out and buying a vise, and for this kind of work it does the job pretty good. Now with these Dean's connectors, the vertical pin is always the minus pin. Get our heat shrink down. Now we do our plus pin. If you're not sure of the polarity, you can just check one of your lipos. This is really important. You don't want to get polarities wrong when it comes to working on mini quads. It's a great way to destroy stuff, is getting polarity wrong. And now I'll just heat shrink this up. And now we already decided that this was going to be the back of the quad. And now we want to just go ahead and check our battery cable length. I think that's a pretty good length. We don't want it too far inside, otherwise it's going to be a pain to plug into the battery every time. But it's not so long that it's going to get in the way of things. So we've got a plus pad here and a minus pad here. And now I'm just going to attach our main LiPo wire to our board. And obviously we want to make sure that this is a real good connection. Again, I'm real sorry, it is hard to do this with a camera in your face, but I'm trying to show you guys how it's done. And give it a real good pull, like definitely you don't want that coming off. And then here I need to be careful that I don't actually bridge to the plus. Just give it a second to set and then give it a good pull. Like I'm actually putting quite a bit of pressure on there. I will also end up putting a cable tie there just as strain relief, because the last thing you want is your LiPo shorting out in a crash. So yep, just a quick cable tie through there. Doesn't need to be stupid tight. It's literally just as like a first point of protection. Okay, so now we get to put in our flight controller. This way is the front, this way is the back. The arrow for the controller is this way, so we know we need to do the offset, but we have all our cables in place ready. The way that I've laid it out, it's pretty easy to tell which is which. I could have labeled it if I wanted to, but I don't really need to. I know that this is motor 1, and I can see that this cable goes to ESC 1, and then I can see that that is ESC 2. This one must be ESC 3. Because it's the one with the beck, and then this one must be ESC 4 because it's the one without the beck. So now guys, if you see that, I think that that is pretty damn tidy. The only thing we're missing now is the receiver and some propellers, which we will do in the next video. Awesome. See you on the next one. Woohoo!